Assalamualaikum. My name is Ahmed Ishtiaq Nahid. My matric number is 1829947. First, I'm gonna talk about computer components. The Neumann architecture, also known as the von Neumann model, is a computer architecture based on a 1945 description by John von Neumann. It is the basic foundation of the modern day computer. Here you can see there are two parts like data and instructions are stored in a single read-write memory, and the contents of this memory are addressable by location without regard to the type of data contained there. We can divide computer components into two parts: programming in hardware, programming in software. Let's talk about computer hardware. The term hardware refers to mechanical device that makes up computer. Computer hardware consists of interconnected electronic device that can use to control computer's operations, input and output. Examples of hardware are CPU, keyboard, mouse, hard disk, etc. Here you can see the data is inputted and the sequence of arithmetic and logic functions are run by the core unit, and the result is shown.
Next, we have computer software. Programming software is also known as programming tool or software development tool. Programming software is a program or set of programs which helps the software developers by assisting them in creating, debugging, and maintaining other programs and applications. Instruction codes are inputted, checked by instruction interrupter. A control signal goes to general purpose arithmetic and logic functions. There more data can be inputted and the final result is shown. Next, we have addressing mode to talk about.
Addressing modes are an aspect of instructions set architecture in most central processing unit (CPU) designs. An addressing mode specifies how to calculate the effective memory address of an operand by using information held in the registers and or contained within a machine instruction or elsewhere.
Most common addressing technique or modes: immediate, direct, indirect, register, register indirect, displacement, and stack. And now I'm gonna talk about all these modes in short. First, immediate addressing. This mode can be used to define and use contents or set initial values or variables. Typically, the number will be stored in 2's complement from the leftmost bit of the operand field is used as a sign bit. Advantage of this immediate addressing: no memory reference other than the instruction fetch is required to obtain the operand, thus saving one memory or cache file in the instruction cycle. Disadvantage: the size of the number is restricted to the size of the addressing field, which in most instruction sets is small compared with the word length. Direct addressing: address field contains the effective address of the operand. Effective address EA equals to address field A was common in earlier generations of computers, requires only one memory reference and no special calculation. Limitation is that it provides only limited addressing space. Register addressing: address field refers to a register rather than a main memory address. EA is equals to R. Advantages: only a small address field is needed in the instructions. No time-consuming memory reference are required. And the disadvantage is the address space is very limited.
Relative addressing: the implicit reference register is the program counter (PC). The next instruction address is added to the address field to produce the EA. Typically, the address field is treated as a 2's complement number for this operation. Thus, the effective address is a displacement relative to the address of the instruction, exploits the concept of locality, saves address bits in the instruction if most memory references are relatively near to the instruction being executed. Then we have displacement addressing. Combines the capabilities of direct addressing and register indirect addressing. EA is equals to A plus R. Requires that the instructions have two address fields, at least one of which is exploited. The value contained in one address field, value A, is used directly. The other address field refers to a register whose contents are added to produce the effective address. Most common uses: relative addressing, base register addressing, indexing. Base register addressing. The reference register contains a main memory address. In the address field contains a displacement from the address. The register reference may be explicit or implicit. Exploits the locality of memory references. Convenient means of implementing segmentation. In some implementations, a single segment base register is employed and is used implicitly. In other, the programmer may choose a register to hold the base address of a segment and the instructions must reference it explicitly. And finally, we have stack addressing. A stack is a linear array of location. A stack is a reserved block of locations. Associated with the stack is a pointer whose value is the addressing of the top of the stack. And there is the end of my slides. Thank you so much.
Assalamualaikum, I'm Shirazul Marzan and thank you so much to my previous presenter, Brother Istek. Now I'll talk about the computer function. It's all about CPU, the register memory, input and output. Basic instruction cycle. The basic function performed by a computer is execution of a program which consists of a set instructions stored in memory. The processor does the actual work by executing instructions specified in the program. Instruction processing consists of two steps, fetch cycle and execute cycle. The processor reads instructions from memory one at a time and executes each instruction. Program execution consists of repeating the process of instruction fetch and instruction execution. The instruction execution may involve several operations and depends on the nature of instruction. Program execution halts only if the machine is turned off. Some sort of overcoverable error occurred, or a program instruction that halts the computer is encountered. CRAM execution. The PC contains 300, the address of the first instruction. This instruction is loaded into the instruction register IR and the PC is incremented. The process involves the use of a memory address register and a memory buffer register. For simplicity, these intermediate registers are ignored. The first 4 bits in the IR indicate that the AC is being loaded. The remaining 12 bits specify the address from which data are to be loaded. The next instruction, 5941, is fetched from location 301 and the PC is incremented. The old contents of the AC and the contents of location 941 are added and the result is stored in the AC. The next instruction is fetched from location 302 and the PC is incremented. The contents of the AC are stored in location 941. Here, instruction address calculation determine the address of the next instruction to be executed. Usually, that involves adding a fixed number to the address of the previous instruction. Instruction fetch read instruction from its memory location into the processor. Instruction operation decoding analyze instruction to determine type of operation to be performed and operand to be used. Operand address calculation. If the operation involves references to an operand in memory or available via input or output, then determine the address of the operand. Operand fetch. Fetch the operand from memory to read it in from input or output. Data operation. Perform the operation indicate in the instruction. Operand store write the result into memory or out to input or output. Interrupts and instruction cycle. With interrupts, the processor can be engaged in executing other instructions while an input or output operation is in process. The input or output module for the external device sends an interrupt request signal to the processor. The processor responds by suspending operation of the current program, branching off to a program to survive that particular input or output device known as an interrupt handler, and remusing the original execution after the device is survived. Interrupt handler program is generally part of the operating system. Instruction cycle with interrupts. To accommodate interrupts, an interrupt cycle is added to the instruction cycle. In the interrupt cycle, the processor checks to see if any interrupts have occurred, indicated by the presence of an interrupt signal. If no interrupts are pending, the processor proceeds to the fetch cycle and fetches the next instruction of the current program. Here, instruction cycle with interrupts. To accommodate interrupts, an interrupt cycle is added to the instruction cycle. In the interrupt cycle, the processor checks to see if any interrupts have occurred, indicated by the presence of an interrupt signal. If no interrupts are pending, and the processor proceeds to the fetch cycle and fetches the next instruction of the current program. If an interrupt is pending, it suspends execution of the current program being executed and serves its context. This means saving the address of the next instruction to be executed and any other data relevant to the processor's current activity. It sets the program counter to the starting address of an interrupt handler routine. Sequential interrupt processing. Disable interrupts while an interrupt is being processed. Processor can and will ignore that interrupt request signal. If an interrupt occurs during this time, it generally remains pending and will be checked by the processor after the processor has enabled interrupts. Thus, when a user program is executing and the interrupt occurs, interrupts are disabled immediately. After the interrupt handler routine completes, interrupts are enabled before resuming the user program, and the processor checks to see if additional interrupts have occurred. The approach is nice and simple, as interrupts are handled in strict sequential order. The drawback to the preceding approach is that it doesn't take into account relative priority. Time sequence of multiple interrupts. In input-output module can exchange data directly with the processor. Processor can read data from or write data to an input-output module. Processor defines a specific device that is controlled by a particular input-output module. In some cases, it is desirable to allow input-output exchanges to occur directly with memory. The processor grants to an input-output module the authority to read from or write to memory so that the input-output memory transfer can occur without tying up the processor. The input-output module uses read or write commands to memory, relieving the processor of responsibility for the exchange, and this operation is known as direct memory access. And now I would like to invite Brother Istiak again to discuss about the instruction structures. Thank you.
Assalamu alaikum. So now we will show you how is the execution of the program happens. The hypothetical machine has 4 opcodes. 2 instructions are from the memory and it has 2 in-output instructions. These instructions are in the binary numbers, so we need to convert them to hexadecimal numbers. For the first binary, it's going to be, after conversion, it's going to be 5. For the subtract, it's going to be 2. For the load, it's going to be 4. And for the store, it's going to be 6. These are the opcodes that they are going to be inside our program execution. For this program, we will rewrite the first instruction, which is load AC from device 7. So the device needs to be stored in 4-digit numbers, so it's going to be 0007, and for the first digit, it's going to be for the instructor, which is 4, so it's going to be 4007. The second instruction, we need to add the contents of the memory location 940. As we mentioned before, that we have 4 digits, so the first digit is going to be for the instructor, which is going to be 5. So 5940 is going to be for the subtraction the same, and also for the store it's going to be as the load but with different instructor. These numbers are going to be the contents of the memory location. Next, it says that the next value is the value retrieved from device 7 is 8. And then we're only going to put the next value in here. The location 940 contains a value of 1. And for the memory location 941, it contains a value of 3. Note that all the numbers in here are going to be in 4-digit numbers. In the CPU, we have the program counter register, which is the PC, and AC, and the instruction register. We are assuming that the first value in the PC is going to be 300 as a starting value, and taking the contents of memory location and put it in the instruction register, which is 4007. So now we will load the AC from device 7, which is we're going to look for the device 7 and take the content of it and put it in the AC.
Okay, Assalamu alaikum warahmatullahi wabarakatuh. I am Hassan, the last presenter of this topic with the matrix number of 1827297. Before I start, I wanna say that of course I would rather to be in the classroom right now with my classmates, explaining and presenting to them the topic in front of our beloved teacher. But with the current situation of coronavirus and all this situation, the pandemic, inshallah, in the future with the vaccine and so on, we'll be able to do it. And also, I want to thank the previous presenter, Sister Noran, for explaining and rewriting the instructions in such a form. Okay, without further ado, let's start. After we finish the first two steps, we'll move on to the third step, which says add contact of memory location 940. And before that, take note that after each step, we will add one to the PC. So we will take the memory location of 301, the value of the memory location, and we will move it to the IR. And it says add contacts of memory location 940. So where is the memory location 940? Here is it. Here it is. This is the value of the memory location 940. So we will take the current value of the AC and the current contact also for the memory location 940 and simply add it together. And the new value we will store it back to the AC. Okay, done with this step. The next step also we will repeat the same process of adding one to the PC. So we'll take the value of the memory location 932 and we will store it in the IR. After that, it says subtract contacts of memory location 941. So where is the memory location 941? Here is the memory location 941 and here is the contact of it. So we will take the current value of the AC and we will take the contact as well of the memory location 941 and simply subtract them. So the new value we will also store it back to the AC. Okay, the second step, the fifth step will be also who can guess like what we should do, like the first thing we should do. Okay, alright, we'll add one to the PC as usual after each step. So we'll take the contact of the memory location 303 and we will store it in the IR. So after that, it says, the instruction says store AC to device 8. So we will store the current contact of the IR to the inputs output device 8. So we will store it here, and after that we will take the current value of the AC and we will store it in the memory location 941. So it's moving, and that's it. It's stored in the memory location 941. And after that we have finished the steps and we have done the instructions. And before we can call it a day, of course we should not forget to support our brothers and sisters in Palestine and raise our voices and say stand up with Palestine, with the praise, with anything that we can do to support them. Of course, they are our brother and sister. And that will be the presentation of this topic for our group. And that's all. May Allah bless you. And Assalamu alaikum wa rahmatullahi wa barakatuh.